Domain of a composition is probably one of the most difficult things on this test. You have to look at both functions. So first, we look at f because that's the one that we plug into first. So we need the domain of f. So you look for the restriction on f, which is just that you cannot have negatives inside square roots. All right. Domain of f of x is the radicand, the part inside the square root, cannot be negative. It has to be greater than or equal to 0. So you solve that. And you get 2x is greater than or equal to 6. So x has to be greater than or equal to 3. If you put that as an interval, that would be 3 to infinity. Since it was or equal to, it gets a bracket. And there's our domain of f. We also need to look at the domain of g because we're going to take f and plug it into g. So what is not allowed for g? The domain of g, you're not allowed to divide by 0, so that means the denominator cannot be 0. X cannot equal 0. But we actually don't care about just the denominator there. We care about plugging f into g. So instead of x, we're plugging f in there. So the square root of 2x minus 6 is not allowed to be 0 because that's what gets plugged into g. So you do look at the domain of g, which is x cannot equal 0, but rather than x, you put f because that's what gets plugged in for x. And then solve this out. So to get rid of the square root, you square both sides. Move the 6. Divide by 2. X cannot equal 3. So we take what we just got, x cannot equal 3, go back and look at the domain of f. Domain of f, we started with from 3 to infinity, and we're told that x cannot equal 3, so we change that bracket to a parenthesis, and we're done. So you start with the domain of whichever function is written at the back. Domain of f is 3 to infinity. Then you take f into the domain of g. Domain of g is x cannot be 0. Replace x with f, solve it out. All that told us was x cannot equal 3, so you got to take it out. You change the bracket to a parenthesis.